Assalamualaikum warahmatullahi wabarakatuh. Okay, we are from the group members. We will present about the simulation system on the KFC at Basco Hotel. The seventh group member consists of Eli Rahmi, Soki Abdillah, and Dira Ersanti. Next, from the background, KFC is the one of the franchise which lie on Basco Grand Mall Padang. It has 3 servers, but it has busy time on the holiday when the afternoon or evening especially. On this research, we found the problem that when busy time, some customer who are wait leaves the system caused by the queue. They don't want to queue in the server. To formulate the problem, we can see that the system will be modeled and simulated to minimize the total waiting time of customer in the system, and there are no more customers who leaving the system. Okay, this is our main objective, and this is the problem exactly. Next, our main objective of this research is the objective of this project. It can reduce the total waiting time of the customer and increase number out of customer in the system. It means that our objective is to minimize the customer who don't want to queue in the server. For collecting the data, we collected data on the KFC in 2 hours from the 5 p.m. until the 7 p.m. The observation is done for 1 day, and the amount of data obtained are 51 customers. It consists from 3 servers. Next, we can see that the time between arrival distribution on this case. We can see that the time between arrival is appropriate to exponential distribution. It means that the arrival from the customer can appropriate to exponent. Then next is the service time of the distribution in server 1. We can see that from the histogram we can fit that the Erlang distribution is the most appropriate one to the service time on the server 1. Next, for the server 2, the distribution of service time will be fit by the beta distribution, because we can see that the histogram and the result from the input analyzer, we can see that the expression is 0.07 plus 9.73 for beta distribution. Next, for the server 3, we can see that the service time distribution on this same with the server 1, it appropriate to beta distribution. Next, we can see that the system modeling now. From the left one, we can see that the customer come. We use the input analyzer and use the expression of the input analyzer to fit the customer inter-arrival time. Then on this case, we use exponential distribution. Then for the second node, we can see that the decide node. On this node, we can assume that there is the customer can be queued or not. It depends on their choice. On this decide node, we can see that there are 3 arrows that come to the server 1, server 2, and server 3. It means that the customer have their choice. Then, if they are not want to queue, they will depart from the system. Next, for the server 1, server 2, and server 3, at the last sheet, we can see that the distribution on this process server depend on the beta distribution and Erlang distribution. That we can assume that on the service time, we build an arena appropriate to those distribution. Next, the record node. On this case, we just use the record node to recap the data and recording it and to influence the result on the repo. Next, we assume that after the customer service by the server, then they will depart from the system. Next, this is the result of simulation in Arena software. We can see that on the queues repo, we can see that the server 1 queue or waiting time is 0.22 hours. That means that equals to 12.61 minutes. That's from the second one from the other table. We can see that number of waiting in server 1, 2, and 3 is 2.02 and 1.95 and 1.05. Okay, that's the next step we done that verification data. On verification, we compare the model result with the actual data and it can appropriate with actual data. The other reason, the model can run clearly without error. That's the kind of subjective methods that we compare those two data and our model. Next, for the validation data, we use SPSS to do the hypothesis test. Especially this is the example for the server 1. We can see that the significance of two-tailed hypothesis test is bigger than alpha, and from this hypothesis, H0 is mean that mu equals to 12.6 minutes, but H1 as an alternative choice, mu is not equals to 12.6. From this table, we can conclude that the data, the H0 will be accepted because the number of significance two-tailed bigger than alpha. So we can conclude that the data from the server 1 mean service time is equals to 12.6 minutes. Which has been picked from the Arena program that result from our model. Okay, from those all steps of our presentation, we can conclude that the existing system at KFC Basco Grand Mall has not been optimized yet because the number of customer waiting on the system is small enough, but the waiting time more than 10 minutes. Based on the verification and validation data in our research, KFC Basco Grand Mall should add more server in the system, especially in weekend if they want to use their money. Okay, that's all our presentation about the simulation system, about the KFC queuing system. Okay, thanks for the attention. Wassalamualaikum warahmatullahi wabarakatuh.